Another use of our exponential equations is in working with Newton's law of cooling. Now, Newton's law of cooling is the equation y of t is equal to t sub s plus t sub 0 minus t sub s in parentheses times e to the kt power, where T sub S is the temperature of the surrounding area and T sub 0 is the original temperature of the item that is either going to be cooled or is going to be heated up. And then we have our K is our constant that we need to find for a particular situation. So here we have when freshly baked bread is taken out of an oven, the internal temperature is 190 degrees Fahrenheit. It is set on a rack to cool in a 72 degree Fahrenheit room. If the bread's temperature is 171 degrees Fahrenheit after 15 minutes, how long will it take for the bread to cool to 100 degrees Fahrenheit? So let's take each of these components from the equation and try to find out if we know their value. First of all, T sub S. So capital T sub S is the temperature of the surrounding environment. So here our T sub S is our temperature of our room, which is the 72 degrees. Now T sub 0 is the original temperature of the item. So here our temperature T sub 0 is the 190 degrees. And then we also have that our Y of a particular temperature that we have a pair of information so that we can find our K value. We have that the temperature is 171 degree Fahrenheit after 15 minutes. So that gives me that Y of 15 is equal to 171. Now notice we have a small case t for time, and we have the two different subscripted capital T for temperature of the surrounding environment and T sub 0 for the temperature originally of the item. So it's really important that you keep your variables case sensitive and that you very carefully remind yourself what each thing stands for. Now, the first thing we're going to do is use the information to get as simplified as we can. So we have y of t is equal to, well, t surrounding is 72, plus in parentheses, t sub 0 is our original temperature, 190, minus the t surrounding, which is the 72, and then that's times e to the kt. So we have y of t is equal to 72 plus 118 e to the kt. So we want to now use our y of 15 is equal to 171 to find k. So the 171 is the output, so that's on the left side of the equation. So I have 171 is equal to 72 plus 118 e to the k times, small case t is times, so that's 15 minutes. Solving this, we'll subtract the 72 from both sides and we'll get 99 is equal to 118 e to the, well, k times 15 is 15k. Divide both sides by 118. I have 99 divided by 118 is equal to e to the 15k. And then our variable k is caught up in the exponent, so we're going to take the log of both sides, and it's base e, so we're going to take the natural log of both sides. So I have the natural log of 99 over 118 is equal to, and then recall that the natural log of e to the 15k is just the 15k from properties of the natural log, and exponentials with the same base are inverse functions, and so when you compose the two you just get the original input. Solving for k, we'll divide both sides by 15 and we get k is equal to the natural log of 99 over 118, that expression divided by 15. Now certainly we could go to a decimal approximation and carry those digits pretty far out, but we're just going to keep it in exact form and do the calculations all at the end. So right now what we have is y of t is equal to 72 plus 118 e to the, I know now that k is the natural log of 99 over 118, that divided by 15, and that's my coefficient in front of t. So then it says if the bread's temperature, now it asks how long will it take for the bread to cool to 100 degrees Fahrenheit. So that's the output, that 100. So we're going to put that 100 on the left side of the equation and then solve for t. So I have 100 is equal to 72 plus my last term here, subtract 72 from both sides, and then divide both sides by 118 and simplify, and you'll get 14 over 59 is equal to e to the natural log of 99 over 118 divided by 15 t. Take the natural log of both sides. I have the natural log of 14 over 59 is equal to, and the natural log of e to the power is just going to be that power, so that's the natural log of 99 over 118 divided by 15 times t, and then solving for t, we'll multiply both sides by 15 and divide by the natural log of 99 over 118. So my t is equal to 15 times the natural log of 14 over 59, over natural log of 99 divided by 118. And approximating that, running it through the calculator, you'll get that that's approximately equal to 122.901657, and we want to round this, let's round this to the nearest minute, and we'll have 123 minutes. So the time is approximately 123 minutes, which is 2 hours and 3 minutes.